Today we're going to be solving some more exponential equations, but we have an added piece to the puzzle where we're dealing with some fractions. You guys can see this 1/5 right here. And a 125, we need to get these to have the same base so we can use our strategy that we developed in the last video. Now 125 can be written as 5 to the third power. So we have a base of 5 here, and we have a 5 there, but it's written as a fraction. So 1/5 and 5 are not the same thing, but we can get them to have the same base using something called negative exponents. So we're going to do some brief background on negative exponents, and then we'll be able to go back and finish solving that one. Now, negative exponents work this way. If I have a number, let's pick 10 for example, and I give it a negative exponent, let's say to the -4th power, I calculate that by doing the following. I'm going to put the 10 in the denominator of the fraction. So it was in the numerator, it's going to switch to the denominator, and that exponent then becomes positive. So we have 1 over 10 to the 4th is 10 to the -4. Also, if we start with a negative exponent in our denominator, let's say 1 over 10 to the -4th, then that would switch to the numerator and become positive. And so we can switch numbers from numerators to denominators by using negative exponents. Okay, we wanted 1/5 to be able to have a base of 5, so let's use our negative exponents to do that. 5 has a power of 1 on it, and so when we switch it, put it in the numerator, that would give it an exponent of -1. So now we have a base of 5, and we're going to be able to use our tools that we had before. So let's go ahead and do that over here. Instead of writing 1/5, I'm going to write that as 5 to the -1st power. And now we can see we have the same base on both of these. Now we can't forget, we still have that x right here, so we're going to put that outside there. And we're going to need the power rule to simplify this. So that would be -1 times x, or 5 to the -x power, equals 5 to the 3rd. And now we're set up so we can use our tool where we thought, oh, this exponent needs to be the same as that exponent, so -x needs to be equal to 3. We'll finish this out by dividing by -1, and we get x equals -3. Our next problem, we run into the bases that are difficult to match up. 216 is not 36 raised to any nice power, and so we're going to break both of these down like we did in our last video, and we're also going to use negative exponents to deal with this fraction. So 36 can be written as 6 squared. And then we still have this exponent out here. That would be to the -3x plus 3. We'll simplify this a little bit later. Now 216, that one's not easy in my head, but I'm thinking maybe I can get it to have the 6th power. So I know 6 squared is 36. Well, what's 6 to the 3rd power? Plug that into a calculator and you'll find that that is 216. So we can write 216 as 6 to the 3rd power. But the problem is it's in the denominator. So we're going to fix that by using our negative exponents to get it up into the numerator. That makes it a -3rd power. So we now have a base of both 6's right here. We still need this, so we have to the x plus 1 power. Use the power rule, we get 2 times 3x plus 3, so we'll have to use the distributive property. 2 times 3x is, -3x is -6x. 2 times +3 is +6. So we get 6 raised to that power, -6x plus 6. This one we'll also have to distribute. -3 times x is -3x, and -3 times 1 is -3. So we have these exponents now that need to match up. -6x plus 6 must equal -3x minus 3. Let's add the 6x. That gives us 6 equals 3x minus 3. We'll add the 3 to that side, and that gives us 3x equals 9. And then we'll finish it out by dividing by 3 to get x equals 3. And we're finished with this one. We've got one more to do, and this one is pretty tough. And the reason for its difficulty is because on the one side of the equation over here, we have our variable in our exponent, and on the other side, our variable is not in our exponent. So we're not going to be able to use our strategies for linear because this exponential part messes us up. We're not going to be able to use our strategy for exponential because this linear part messes us up. They don't work nicely together. So we're going to use our tool that we developed with our graphing calculator a couple of videos ago, and we're going to separate these two into two equations. So this is y equals 4/3 x minus 1, and this one will give us a second equation, y equals 1/3 to the power 2x minus 1. I can then go to a graphing calculator, put these in, and find the intersection, and then that will give us our x value that we need. So we're going to go ahead and do that on the computer. Take a look over there. You can see that I've graphed those two functions now. Up here in the input bars, you have f of x equals 4/3 x minus 1. I've used function notation, so I can give these two a different name. And in the second one, we have g of x equals 1/3 to the power 2x minus 1. Now, to get an exponent in GeoGebra, we're going to use the caret button on our keyboard, which is found on key number 6. If you press Shift 6, that will give you the caret button, and it puts it up in the exponent. So that's how we did that. Now we've got the two graphs over here. You can see that they intersect, and if you click on this point on the intersection, you see that that location is at 1 and 0.3 repeated, so 1/3. The only value we cared about from the original problem was our x. We have our y value just so we can graph them, but the x value is what we're looking for, which you can see is 1. So our solution is x equals 1, and we're done.